So the one we're starting off with is this one here. Now we're given these three equations, and we're wanting to solve for it. Now if we look at this here, x, y, and z are all nice ones to eliminate first. Because x, if we choose to eliminate it first, it doesn't matter which one we pick as the eliminator. I can turn either one of them into 5x nicely. We multiply by 5. Y, 5y, same thing. We can pick either one of the 1y's, multiply by 5 to get the other. And then we have z, and z. All the z's are actually have the same value. Which one do we want to eliminate? X, y, or z? X or z. So we pick z as the variable we're going to eliminate first. Now we need to pick an eliminator equation. So we're really picking the equation we can turn into the other two nicely. Normally there's one with the smallest number in front of z. But here, since they're all 1, it really doesn't matter. 1, 2, or 3, which one? 2. Yeah, because at this point, it really doesn't matter which one we pick as the eliminator. We just need to pick one. So, what we're needing to do, and the reason we need to pick one is so that we don't use it twice. Because whichever equation we use as the eliminator equation can't be the one of the two that we have left over. So eliminator equation is purely to remove that variable from the other two. So by selecting it or saying which one we're using prevents us from using it as an eliminator equation and one of our two main equations. Because if we use it as the eliminator equation and eliminate it, the one of the equations our primary are, we'll end up getting 0 equals 0.
It will cancel itself out completely.
On the right side, x minus y. So the eliminator is the one we picked in the middle, yes? So the x minus y minus z equals -3. So that's the one we're going to, yeah. It doesn't help that the top equation 1 and equation 2 are essentially the exact same thing. Yes. So we'll do the one on the left first. Z's are already the same, even though the signs are opposite. They both have the same number in front of it, as 1. So when we look at this here, we need to see, do we need to add or subtract? So if we said subtract, we'd have z minus negative z, 1 minus negative 1. 1 minus negative 1 is 2. 1 plus negative 1 is, so in this case, we would need to add. When the signs are opposite, we add. When the signs are the same, we subtract. So if the signs were both positive, positive, we subtract. If it's negative and negative, we still subtract. So adding here, 5x plus x, 5 plus 1 is going to be x. Negative 5y minus y. Negative 5 plus negative 1. So it would turn into a positive if we were subtracting a negative. Negative 6y. Z plus negative z, 1 plus negative 1 would be 0 like we wanted. Negative 15 plus negative 3. Negative 18. All right. Now we're going to do the same thing. To the other side. And on the other one, z's are already the same number. Different sign, but same number. And just like with the other one, we're going to add all the way through. x plus x is 2x. Negative y plus negative y. Negative 1 plus negative 1 is negative 2y. Z plus negative z, 0. Negative 3 plus negative 3, negative 6. Questions on how we got here? So, now we need to determine which one we're going to eliminate at. Next, x or y. Sure could. Now at this point here, x and y are kind of nice either way. Because if I wanted to eliminate x next, what would I need to multiply by 2x to get 6x? 3. Same with 2y. So it's easy to get from 2x to 6x or 2y to 6y. Which one do we want to eliminate next? Y. Now, this equation's already set up, it's fine. So we're just going to rewrite it as 6x minus 6y equals negative 18. However, our 2x minus 2y equals negative 6, we still have to multiply it, as we just said, by 3, so that the numbers in front of y can match up. They're both going to be 6, and we can move on from there. So the first thing we can do is distribute the 3. 3 times 2x is 6x. 3 times negative 2y is negative 6y. Negative 6 times 3 is negative 18. Would we add or subtract? Negative 6 plus negative 6. Negative 12. So let's try the other operation. Negative 6 minus negative 6, because the negative negative make a positive. So we have negative 6 plus 6 would indeed be 0. Now again, we can't plug the variables into the calculator, but I can do the coefficients, our numbers in front of the variables. The calculator will do those just fine. So we know we have to subtract all the way through. Because negative 6y minus negative 6y is indeed 0, yes? 6x minus 6x is 0. Negative 18 minus negative 18 is 0 equal to 0. Infinitely many solutions. There is a way to go about actually getting or defining these solutions. And if we went about it and did this, I'm not too concerned on it here, we would have, make sure, negative 2x, depending on how we defined it, y minus 3 comma y comma 0 would be the solution set for this system here, for any value of y. So I could pick a value of y, plug it into y spots, simplify, and it would give me a solution that works in all three. That's why we're saying infinitely many, because any value y we can plug in there will give us a solution for the system. Questions on this here? We're on example 3. Okay. So especially with infinitely many, if we get 0 equals 0, we get a true statement like we just did, especially at the end. If we get all the way to the end at 0 equals 0, it's infinitely many guaranteed. If in the first step, one of the sides becomes 0 equals 0, we just need to do the other side to make sure we get something that's not a false statement. Like the one that we ended yesterday with, 0 equals -7. That's not a true statement, so it's no solution. If the other side gave us an equation still, it's infinitely many, we can move on. Let's look at another one. We're going to look at least one more here. X, Y, Z. Which one do we want to eliminate first? I do Y. Because if we look at the three equations, the top one has 2y, the middle one has 2y, and the bottom one has 2y. So the y values are already all the same. Now we still need to pick an eliminator equation, one to remove the 2y from the other two equations. Top, middle, bottom. Which one do we want to use? So top and bottom are the non-eliminator? Okay. Now because they're all 2y, they're all the same, it really doesn't matter which one we pick. We just need to pick one so we don't use it twice. So we'll do the one on the left first. Now we don't have to multiply it by anything because our y values are already both 2, so we don't have to simplify there. Now determine if we're adding or subtracting, we're specifically going to look at the variable we're wanting to eliminate. So that's our y. So we have -2 and +2. Well, -2 plus 2 is 0. If we did -2 minus 2, we would have gotten -4. Since the signs are opposite, we're going to add. X plus 3x is 4x. You're good. -2y plus 2y is indeed 0. Z plus -z. 1 plus -1 is also -11 plus 7. Almost. Positive or negative. Because the bigger number is negative. -11 plus 7 is questions on what we did here. This is kind of nice because how many variables do we actually have left? We have 4x equals -4, yes? There's nothing that says we can't just say, okay, cool, divide both sides by 4. I have x is -1. Because at any part of the process, mainly it would show up here if it does, where 2 variables eliminate out, solve for it. We're having to find x, y, and z eventually. If I can go on and find x at this point, we're going to go find it. All right. We have 2y and 2y on the other side, yes? We added on the first one, so if we add here 2y plus 2y, 2 plus 2 is 4. We're going to have to minus 2 minus 2 is It's just been coincidental or worked out that on all the ones up to this point, we either added on both or subtracted on both. We don't have to. Because 2y minus 2y is indeed 0. Negative x minus 3x. Negative 1 minus 3 is negative 4x. 2y minus 2y, we already said is 0. 4z minus negative z. 4 minus negative 1. 4 minus negative 1 is positive 5 plus 5z. Negative 9 minus negative 7, or negative 9 minus 7. It's going to be negative. Because we're just taking away from a negative, so it's going to be a bigger negative. Questions on this here? Now, this is different than the ones we had before because I only have one equation with two variables, Jeff. And it's in the form, and we have x and z. Do we know what x is? So I can come over here and say, well, this is 4 times negative 1 plus 5. We can just start solving backwards. We have one of them, so I can solve for the other. 4 times, negative 4 times negative 1 is 4. Plus 5z is equal to negative 16. To get z by itself, we would. Subtract 4 from both sides, because 4 minus 4 is indeed 0. Negative 16 minus 4. Negative, getting bigger negative. You're good. Come on. Yeah, doing some of the subtracting negatives can be a challenge. Last but not least, we would divide both sides by 5. Positive divided, or negative divided by positive will stay negative. 20 divided by 5 is so negative 4. Now we just need to pick one of the first three equations to plug in, negative 1 for x and negative 4 for z. Top, middle, bottom. You're good. I'm just making sure we're looking for y. Yeah. Oh. Would it be 0? Let's see. We can do the top equation. So our x minus 2y plus z. So we'll plug negative 1 in for x and negative 4 in for z. So our parentheses around our negative 1 would just drop. So we'd have negative 1 minus 2y. Our plus negative 4 is the same as minus 4. We do have like terms, our negative 1, negative 4. So we still have negative 2y. But negative 1 minus 4 would be negative 5. So we have everything simplified on the other side. We have all of our like terms combined, so we can start moving things. So we would add 5 to both sides. And lastly, we would divide both sides by negative 2, telling us y is equal to 3. So our solution is the point negative 1, 3, -4. Questions on this here? Yeah. You're welcome. Questions on these here? So 5 problems. It looks like more than 5, but it's just 5. 3, 4, 5, 11, 13. 2 of the problems, one of the 5 is going to be infinitely many solution. One of them is going to be no solution. And the other 3 are going to have 1 point. Okay? Now, what we do tomorrow will have us being able to solve these faster than we've been doing the last 2 days.